Welcome back to Archean, episode 22 of Series 1 playthrough. And here we are back in our little vessel here. I'm going to change out this dashboard, which I set up incorrectly. So the dashboard itself, you cannot make transparent. A screen attached to the dashboard, you can. So the trick here, we got to set up a dashboard, and then on top of that we put the screen. I'm in F2 drone mode, so then so here I'm putting a dashboard down. So the dashboard is right over that set of blocks I put on. Now, since I removed the old dashboard, I have to reconnect it back up. And rename it back to dashboard F, or actually name it, should I say. And if you have not watched the Archean original tutorials from the developers, you really should watch that. A lot of very good information. Like the technique I'm using here is included in that tutorial. Still flying around in drone mode. Now I want to put the screen, so you have a dashboard which is sort of like a bulletin board, and you put things on top of it. And so I'm going to put the screen starting here and zipping it up. Now I'm looking at the little box that tells me how large it is, so 800 by 300 800 by 300 exactly. And I want to set it to matte. It removes the reflection, and I assume that will make it slightly more performant. Okay, I'm going to do something here weird. I'm going to put a small screen over each label, and that allows me to put text over it. So basically I can dynamically put text over each label. I can make the text light up, blink, put icons in there, or whatever I want to do. And I can hear you typing this comment now saying, well, you don't need to do that. If I just would have made the original screen larger, covering this area above the toggle switches, I can easily draw the graphics in that area. I can do all that on one screen. I don't need to create multiple screens. And that is 100% true. The downside of doing it that way is the complexity. Now you really start getting in, you have to partition the larger screen into all these areas. When you blank an area, you can only blank that one small section. And it's all doable, but now it makes the coding far more complex. In this case, I'm leveraging the game itself to maintain, this is a region, it auto clips for me and does all that work for me, with the downside of the overhead. So it's always that trade-off. And generally, part of this series is trying to keep the code itself as simple, as straightforward as possible. Even if I failed a little bit on the my original ore scanner code. All right, so we have two computers. So I'm thinking the computer on the left will be used for controlling propulsion in movement and anti-flip and things like that. And this second computer will be used for displaying information and running the OR scanner, which is, sort of displaying information. So sort of split the two functionality between those two computers. All right, so the first thing, this is the cool part. So I can set that screen to transparent, and that makes this is the whole reason why I want to use it. And put some comments in here, make it a little more readable for everyone. Now, technically, labels, I'm using the concept of labels. There really are screens. So my labels are screens within the context of the dashboard. And we'll call that label, do the first one. Another thing too is because I put the main screen up first, it's given channel 0. As I created each individual label, each individual screen over the toggle switches, they were given the numbers 1 through 16 in sequence. So basically, switch 10 has the mini screen above it, which is channel 10. So everything sort of lines up by doing it in that sequence. That makes the coding a little easier. All right, and we blink the screen. Voila. And this is the big improvement here. I can put information on here without sort of blocking the screen. This is why I don't have a computer in front, so I can kind of reach the buttons. You could argue the seat could be a little further up front. Now I'm going to mat all these out. We'll speed this up a little bit. Boom, 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 boom. I sort of like the computer buried into the floor there. All right, so we got a bit of coding to do here. So we got our screen, got label 1. Obviously, for line 3, we could replicate that, label 1 through 16. Just doing the 1, just kind of play around with it. And I'm not, 100% sold on this technique. I just figured, well, let's just give it a shot and see how it works out. Why not? So because it's basically a screen in its own right, we can blank it, if I can spell blank. In this case, there's no reason to make it transparent since there's a cube behind it. So we'll just make it background of black. Could make the background white. Not sure if a white background and black text or black background and white text look better. I can play with that and try it. I don't do it in this episode, but in the future. Okay, so I'm going to put a little bit of text in there, and we're going to call it scan. This will turn on our scan, and the text is a little big. Okay, scan. Looks about right. Yeah. Could almost argue we have too many switches here. Now, because I have this set up, I could change the color when it's turned on. So make it green, I guess. When the switch is toggled on, make the text green. Kind of indicate make it super obvious it's turned on. That's too small. Now, a label allows you to do fractional text sizes, but with the screen, you can't do fractionals. In a way, if you use a high definition screen, then because it's double the density, it sort of gives you like 1.5. So, for example, the difference between a high definition screen and a normal screen is a factor of 2. So if I have a normal screen, I really wanted 1.5. If I made that a high definition screen, that effectively would be 3. So then a text of 3 on a high definition screen would be on a low definition, a normal screen would be 1.5. So it does give you more sizes of text if you needed to by using high definition. I decided to not do too much and just go with the low resolution screen or normal size screen for now, and that's fine. Now I'm going to play with the label for comparison. So that's just okay. So that's what if we just do this, the plain old label? Let's just, and okay, the background is the default. And we'll center it like the other one. Now here is, once again, it's all standard sizes, so we can only do, I guess we have, I'm trying to get the same size. It's kind of, maybe that should be one more. So label almost looks like it's high definition, the way it works. I'm using a paint tool so I can paint the background. Okay, we'll make it matte black. Okay, so it looks the same as the others, but we have to change the coloring here. You know, I just don't get that white type color in there. And this is, I think it's, you know, this is based on reflection, so it's not a label is not a light source, which is the big difference between a label and the a screen. A screen is effectively a light source, but a label is not a light source. In other words, if I turn off my suit lamp off, I think you won't even be able to read that label now. Here I am trying to play around with the coloring, and I'll speed this up while I F around a little bit. I can make it red, but of course it can't be dynamic. And you saw when it goes off, I turn my suit light off, and of course you can't see it at all, but you can still see the active display. I was thinking about, I don't really like that. We're going to put back the original screen. Now they all don't have to be screens. I could have some as high definition. So if I have a particular area over a switch that I want more detail, I can always go to it high definition just for that one toggle switch. All right, so that's enough mucking around. And we want to start pulling information from these sensors, which I need to name all this stuff. So I'm going to 5x this. I'm going to go through and make sure the things I want to read have reasonable names. I'm going to put a connection on the cargo so I can read contents of that. Make sure the anchor is named. We'll connect to the battery so we can read the charge. Call that batteries. And we have a beacon. I just renamed that, and I got to make sure I put the pivot and the ore scanner and the terrain scanner and all that. And in those cases, I did the bridges. All right, so we now everything named. So now we need to go ahead and get some more code here. What I want to do is build out some code for scanning. Now, this version of the ore scanner is going to be quite a bit different than the last version. So I made a number of changes that I believe will, one, prevent a number of errors that I encountered in the previous implementation. Also, I am simplifying the code. This particular implementation does not change the scan range yet, but it's set up so if the range does change, like for example, if I want to have the increments go, further out and just switch that on and off, it will handle that condition much better than the previous version did. And generally more verbose and hopefully a lot more straightforward the way the code's written. Now, unfortunately, it still takes, 20 so lines of code and whatnot to make it work. And we got to work with the scanner. So we only want to rotate the scanner if we're actually want to scan. That just reduce a little bit of overhead, a little battery power will save. So effectively, there's a rotation speed that's defined that I need to define in the up above as a constant. And if the switch is enabled, then we use that. If the switch is turned off, we make it 0. So when we set the pivot speed, we'll set it either to our default value or to 0. I put a question mark in there because I need to create the constants for this. We'll call this user config. This is somewhat similar to the previous version. Now, another thing I'm doing here also I did not do last time is I will use the OR scanner and the terrain scanner simultaneously. And this course doubles the power requirements for running it, unfortunately. And potentially I could make the terrain part an option. And so like if you're on land and you don't care about the height, then I can just disable that one part with a switch. But right now they're both turned on. And I said it will double the power requirements when running the scan. So in the configuration we have our rotation speed, and I just made up a number. I want to go reasonably fast, but obviously the faster it goes, the better chance of missing something. And generally there's an area. So for example, take gold. There's an area that has gold, but within that area there are spots that have high density gold. So if you're scanning around and you're going fast and you maybe have your deltas between the distances are kind of high, you should hopefully at least find the general area which has like gold, for example. But when you get close and you need to really narrow it down, then you need to tighten that up a bit, which I'll probably go back to the narrow and wide scan or close scan versus distance scan type thing. So in this we need the starting distance, because we have basically when we set both the OR scanner and the terrain scanner, for each channel we set a distance. So we compute all that. So to compute it, we have, well, what's the first distance? How many distances are we going to write out? How many channels are we going to set per tick? And what's the delta between those? So that's those numbers there. In this case, we start at 10 meters. We're going to do 20 channels, and the delta between channels will be 10 meters. And I think another thing too, I think I improved the naming convention used related to OR and terrain scanning. Make a little more sense. I wasn't really happy with the previous implementation naming convention. And this is actually a case where sometimes just a rewrite is a good thing to do. All right, so it spins. Amazing. Okay. Oh, something else I'm going to do with this is I'm going to not use this weird positive negative degree offset I used last time. I'm just going to use a standard 0 through 359 degrees So effectively, forward is 0, to the right is 90, to the left is 270, behind you is 180, and just go with that. I believe that's standard. I don't fly airplanes, none of that. I believe the kind of glance at aircraft gauges, and I believe that's how they work. Well, that's how they do work. It's a simple compass that spins around. So I'm going to go with that technique. That should make it consistent and not get too weird on the positive, negative type thing. And that makes the code a little easier too. Okay, so we have a switch that turns scanning on off. We turn rotation on. If the switch is on to a constant, now we could make this fancier and have speed up and slow down. We can do a lot of stuff, right? There's a lot of stuff we can do with coding. That's by definition of coding. Now, because I have this huge screen sitting in front of me, I can put development information, debug information. So I just put down line 35. I'm just going to put a lot of junk up on the screen there. And I'll work out the format and clean it up over time. Okay, so, all right. So what we're going to do is I'm going to grab the current angle from the pivot, and then this is standard I did before. Because it goes counterclockwise, we want to basically invert it to a clockwise, which is what we use for the degrees. So we just minus times the angle times 360, and boom, we have 0 through 360. And so now we have a scan directions. And what I'm going to do here, just to double check it, we're going to display this on the screen. And that's an error. I was thinking the height, but I want half the width there. Now there are variables out of if you look into Wikipedia related to the dashboard and the screens, the width, the height, the character width, height, all the information is available off the screen. You do not have to hard code this stuff. So in my example, if I wanted to start this at halfway, I could have taken, I think it's taking the screen underscore W divide by 2, and that would give me, halfway on there. And right now I'm just hard coding it. Okay, so that looks a little small. And we got the 2 different text sizes there. Okay, so what apparently happens is that the text size is not persisted across ticks. So within a tick, it persists, but when the tick resets, it resets the text size apparently resets to 1. And so why it doubled? Because on the first init and the first tick are on the same cycle, so that kind of worked. But after that, it went back to the other one. So I have to move the text size into the actual code. So something I found out: the text size only persists within the tick. Beginning of a new tick, it's reset to 1 apparently. Okay, so I'm just double checking that. I'm looking at the scanner. I'm overdoing this right here, and I kind of spin it and look which way it's pointing and look at the direction it tells me, and that's about 270-ish. So 266, that's good. And then that's that's about that way. And probably overdoing this a little bit. And that way is that's good. And okay, so that all looks appropriate direction. Okay, so let's get some more useful code going on here. Oh, and I don't need the decimal points for the scanner direction. I think just have the number in there. Kind of thinking what I'm going to code next now. All right, so now, because there's a tick delay for both the ore and terrain scanners, we need to track the state of the previous tick. And I'm doing this a little bit different than last time. I do track the previous direction. I call it last direction. I call it previous direction now. Previous scan direction, which is similar to what I did before. But for the distances, what I tracked last time was the previous base distance. And then I would compute the individual distances at that point. This time I decided to be a little different, and for each individual distance that I write a channel out for, I'll go ahead and just add the value, append it to an array. So basically you have an array of numbers, and that array will match each individual distance that's written out to the ore and terrain scanner. So if we have, for example, the count is 20, that means the array size will be 20. And because of that, we can leverage that array size. If the array size is 0, then that indicates there is no previous state. So we can skip attempting to read any state because we know there's no state. And this does add a little bit more overhead by adding and removing items from an array. But it gives more flexibility. For example, if the previous state changes range or changes the count or changes the distances, the deltas between, this will all handle that. I don't have to worry about dealing with that. So I can dynamically, change those values because we save the explicit distances per channel. How they're computed no longer matters. So I don't have to basically bring over the method of computation for the last tick. And that just is a nice simplification there. So, and that hopefully should help reduce some of the weirdness I had before. And here I'm just going to add some more stuff while we're here. And we'll just do it for kilometers for now. Well, I'll just probably leave it for kilometers from now on. Okay, so we got speed on one side, scanner direction on this other side. I'm just kind of thinking if I should go in there and clip out the section while I kind of stare at the code for a few seconds trying to think of what I'm going to do here. All right, so if we turn the scanner off, then there's no reason to retain the previous state. Basically what I'm doing here. So I turn it off, we're done. We'll just clear the previous state. Partly because there's a time element too, because if you turn it off and you start moving around and all, and you flip it back on, you don't care about that old state because there's a high chance you moved or something else changed and it's just not useful anymore. So we'll just clean that out. And in case of the array, we just do a clear, so the array is cleared out. As I said before, we use the array size as an indication whether there's any previous state or not. Now technically I didn't have to do line 43, that clears the direction, but just to keep it neat and pretty. And I'm going to put a comment in front of that. I'll notice that in a minute and fix that. All right, so now we look at the last scan distances. If it has a size, so if the size is one or more, non-zero effectively, then we're going to do a for each. This is a place where it makes it somewhat easier code-wise. So we take for each for the last distances. This will give us two things. It gives us the index, which is basically matches the channel. So I decided here, what I did there is I had to check if last distances were, the size. And then we do a for each. But then I realized it doesn't matter because in the case of the for each, if the array is empty, nothing executes inside the for each. So I don't need the if condition. Because effectively, a for each of of an empty array is no action, which is what I want. So I remove that line. And so we get the OR composition off the OR scanner, and we get the height. Now this height, it is negative positive, so sea level is 0, above sea level is positive, below sea level is negative. So if you want to filter out something, like I want to find the nearest source of gold that's above sea level, then I just check the height is greater than 0. Or greater or equal to 0, I guess. All right, so got the OR, got the height, and so that shows how simple that code becomes now. It's simple for each of the last scan distances. We got index, we got a distance, and so at this point of to do, we have the following information. We have the previous, and I misspelled the on 47. I call it last. I'll fix that when I compile it. So 47 is a misspelling, should be previous last distance. So we know the previous scan direction, so what direction of the scanner. We know the distance, which came out of the array. We know the height, which came out of the terrain scanner, and we know the OR composition, which came out of the OR scanner. So we know all this stuff. We know these 4 pieces of information. With these 4 pieces of information, we can do a lot with that. And this is when I realized I misspelled. And in the previous version I used for the quote-unquote sub, last vehicle, I call them last. This time I'm going to call it previous. And it's just staring at me in the face. It's just, I don't understand. I think I misspelled distances, but then I realized I have last there. So we do useful stuff. Long term, what I'm thinking is to keep a sorted list of like the nearest, and just have sort that list and display that on the display, the transparent display. That basically would have the nearest one always, and just maintain a sort list. Right now, I just sort of like dump them all out or display too many items, and that's just not really easy to process. So we'll clean all that up. But first, do the baby steps. We got to at least get the data out. All right, so line 46 through 59, if there's previous scan information, we collect it. We do something useful for that data. Most likely we'll collect it and sort it and display what we're looking for in a way that's far better than what I did in the previous implementation. All right, so now if scanning is enabled, we need to go through and do a new scan. We pull the old data out, let's do a new scan. So we take the previous scan distances and we remove them. So we're going to start with a new array. And then we'll do a repeat loop based on the count, the basic number of channels we're using. Now, in this code pattern, I'm basically removing all the items from previous scan distances and putting back the exact same numbers over and over and over. So I fill the array, I empty the array, I fill the array with the exact same numbers over and over. And yes, that's a quote-unquote perf issue, but it gives me flexibility because I want to do more advanced stuff as I go through. And what you could do, I could have a flag saying, is last information useful, and just maintain the array, or go back to the way I did before, just compute it. And if I only have a fixed range, if I never change, the count or the distance or the start or the delta, then, you can compute it every time, and I would not need the array. But I'm going for flexibility here and some degree simplification, because this makes the code, I think, a little more straightforward. And even if it does add a little bit overhead, since we can turn scanning on and off, and probably what it has to do internally to actually figure out what the real values are is probably way more overhead than filling or emptying a simple numeric array. All right, so we output the values both to the OR scanner and the terrain scanner, and we append it to the list. And for example, I could use a logarithm for computing the distance. It doesn't have to be this, delta. I could be, and so basically, it increases out. And in this case, it'd make it easier here, especially if I dynamically change the logarithm on the fly. This code would handle that scenario, for example. So we're going to say, well, the flexibility. All right, so in theory, scanning, we get the previous stuff. Now, I do think there's a bug in this code, which I need to fix in the next episode, is that I don't actually, am I resetting? Not yet. So what I'm not doing is I'm not setting the previous scan direction. I set it to 0, but I don't actually set it to the proper direction. And I'm looking for W, which is tungsten, and apparently I'm not finding any. Or this is a bug in my code. So let's change it for something we know it's going to find. There's iron around. Okay, so now we're finding stuff. Yeah, notice in the distance, the direction is always 0. Yeah, so I forgot to set the last scan direction. I'll fix that in the next episode. This is sort of the plus side of me doing the voiceover after the video, is I sort of like do another self-review of what I'm coding or writing here. Oh, this is really weird. So I get confused on this one, going, okay, it just doesn't handle this complex of an expression. That kind of sucks. What I forgot is that you can't do floating point numbers using dot, just you have to say 0.40. I can't just say .40. I forgot that. I don't believe that's the limitation of other languages I've used. All right, that fixed that problem. And that means I can go back to this code and do that. And that should put the parent back in there. All right. So if it has something, convert it to a number. And if it's over that, you know, I'm just trying to get the printing so it's not so verbose. And we know we found 78, but there's nothing above 78. So let's put back to 77. We should find something now. Okay, we find something. I need to fix the last direction value, which is no big deal. It'd be a line like under it'd be lines, a new line 62. I'll put that there. No big deal. We'll fix that, and that gives us. So here, and I sit here and I'll play with it a little bit, and you see the height information that's there. Now I can filter on height because it's picking up iron out in the water. So the really good iron apparently was in the water, and the distance will crack that open a little higher. And this is the advantage of having the height. Now I didn't actually check how much power I pulled. I'm still connected to base power. It's a little further out is why I'm not finding it right now. Okay, there it is. Okay, I don't want to make these videos too long, so this is just about the end of this video. I'm sit here. I'm going to kind of play with the scanning a little bit, and then next episode I will fix that bug. And so I think next episode, besides fixing the bug, is I'll work on a sorted list and display like the top nearest hit, and I should make that a little easier. And set it up for gold, and we should go do maybe a little surface gold hunting, because now we can filter the terrain size, so we can filter out any gold that's in the water. So I hope this seems easier than what I did before. As I said, I'll fix that one bug, and hope the demonstration of how I step by step write the code out, how I test it piece by piece, make sure everything works, using the new display versus using a computer console. All right. Until next time, see ya.